Good morning, students. Today we are going to discuss about transistor oscillators. That means transistor act as an oscillator, right? In previous class we discussed transistor act as a amplifier, right, and act as a switch. Today we are going to discuss about transistor as an oscillator. Okay, students, right? So what is oscillation first? Right, then only we are going to see the oscillator, right? Okay, see this. When the speakers go into feedback and make yes hollowing sound, they have broken into oscillation, right? So when the speakers go into feedback and make a howling sound, they have broken into oscillation, right? So this is just little information about oscillation, right? Okay, and then C is transistor and oscillator. See, an electronic oscillator basically convert DC energy into AC energy of high frequency ranging from a few hertz to several megahertz. Mega means 10 power 6 hertz. So oscillator is basically converting device which convert DC into AC energy of high frequency ranging from few hertz to several hertz. That is few hertz to low hertz to high hertz. So that is an oscillator. Okay, students, right? Now basically the oscillators are classified into two types, basic types. Okay, the first one is sinusoidal oscillators and non-sinusoidal oscillators, right? And sinusoidal oscillator to produce damped oscillations and non-sinusoidal oscillator to produce undamped oscillations, right? Okay, so therefore what are the types of oscillators? Oscillators are two types. One is sinusoidal oscillators and non-sinusoidal oscillators. Okay, students, right? Okay, now come to oscillator. Oscillator is a circuit that is deliberately designed to oscillate. Okay, that is oscillator. Oscillator is a device. Okay, students. Continuation. An oscillator is a circuit that is deliberately designed to oscillate. That is, we know that. At the same time, all oscillators are amplifiers with positive feedback. See, all the oscillators are amplifiers with positive feedback. Amplifier, it is a circuit to amplify the weak signal, right? So that process is nothing but amplification. Yes or no? So amplification. But this one is oscillators are amplifiers. So in oscillator circuit, amplifier circuit also present. Yes or no, students? Yes, right. Continuation. Oscillators are used in radio and TV receivers for frequency control and for detection and mixing. So oscillators are used in radio circuits and TV receiver circuits for frequency control and for detection of sounds, detection of signals, and mixing the high frequency and low frequency, mixing the signals. So this is the uses of for oscillators. Okay, students, right? Now come to feedback. I said no, some word feedback. Feedback is used in oscillator circuit. No. Now what is feedback? feedback can be in phase or out of phase. So this is a signal, proper signal, and this is that. So this is input signal, and this is what output signal. See, this is the phase shift or out of the 180 phase. Out of phase means crest and trough comes at opposite times. That is out of phase. The phase back, the feedback is nothing but out of phase. That means out of phase means crest and trough. See, this is one crest and this is one trough. So because the waves transverse wave produce crest and trough, no. So this is the input signal and this is what output signal. So therefore feedback can be in phase or out of phase. Okay students, because the feedback networks used in oscillators, that's why, right? Okay, three parts of an oscillator. See, oscillator consists major three parts, that is wave producing circuit, and then amplifier circuit and positive feedback circuit, right? That is input signal. The wave producing circuit means input signal, and that signal is fed into the amplifier. It has component, it amplify the signals, input signals. Either the signal is weak, it is amplified by the amplifier, then it gives the output. At the same time, a fraction of output fed into the input through the network circuit, that is the feedback. Yes, feedback circuit. See, a part of output fed into the input through this feedback circuit. Yes, feedback is can be phase or out of phase. Says or no? That's why, right? Okay, these are the three parts of oscillator. What are the three parts of oscillator? Input circuit and amplifier circuit, feedback circuit. These are the three parts of the oscillator. Okay students, right? Circuits, transistor circuit, oscillator circuit. See, this circuit generate a constantly increasing and decreasing current. Constantly increasing and decreasing current. At the same time, the frequency of the varying current is how many times per second, and the current is increased and the current is decreases. Again I'm telling, the frequency of the varying current is how many times per second the current is increased and decreases. And the unit of measure for frequency is hertz, and which represent one complete cycle per second. One complete cycle per second. Number of waves per second is the frequency. That frequency it measured in hertz. Okay, hertz is that. Okay students, right? Types of transistor oscillator. So what are the types of transistor except basic types, right? See, there are 5 types. First one is tuned collector oscillator. Second one is Colpit oscillator, Hartley oscillator, phase shift oscillator, and Wien bridge oscillators. So these are the exceptional types of oscillators. Okay students, but basically sinusoidal oscillator, non-sinusoidal oscillators. Okay students, right? First one is tuned collector oscillator. Yes, this is the circuit, right? The NPN transistor content common emitter mode is in same amplification process. You need not worry about this diagram. Thus you should know what is tuned collector oscillator. Okay, yes, just you should know. See this, Figure shows the circuit for tuned collector oscillator. Tuned collector oscillator is the types of transistor. LC oscillator. L means inductor, C means capacitor. Where the tuned circuit, that is tank circuit, consists of transformer and capacitor is connected in the collector circuit of the transistor. At the same time, tuned collector oscillator is of course simplest and basic type of LC oscillator. So tuned collector oscillator is the basic type of LC oscillators. Okay students, right. Next, Colpit oscillator circuit. See, this is that NPN transistor, okay, and capacitor circuits, and this is the output, and this is the input through the resistance, right? Okay, so this circuit produces a frequency. That frequency is F is equal to 1 by F root LC. Okay, I'll tell you the formula later. Okay students, right. Hartley oscillator. Yes, Hartley oscillator. So this is the circuit for the oscillator. Okay students, now see this. This Hartley oscillator is an electronic oscillator circuit in which the oscillation frequency is determined by the tuned circuit, consists of capacitors and inductors. That's why S is an LC. L means what? Inductor. See, this is the inductor coil, and capacitor. This is the capacitor. So the frequency tuned circuit consists of capacitor and inductors. Okay, right. Phase shift oscillator. So the phase shift oscillators has resistance and capacitors, that is resistors and capacitors, right? And it has circuit operation and more advantages and disadvantages. Okay, right. Weinbridge oscillators. Okay, thus you should know the details about Weinbridge oscillator, right? See this. The Weinbridge oscillator is the standard oscillator circuit for all frequencies in the range of 10 Hz to 1 MHz. Yes, is the standard oscillator, right? What is the range? 10 Hz to 1 MHz. Okay, it is the most frequently used type of audio oscillator. It is the most frequently used type of audio oscillator as the output is free from circuit fluctuations and ambient temperature. Okay, so you should do the range. And the Weinbridge circuit originally developed by Max Wein in 1891 for the measurement of impedances. So there are 2 points in this paragraph. One is the range of Weinbridge oscillator 10 Hz to 1 MHz, and it is mostly frequently used in audio oscillators. Okay students, right. Come to this circuit. 3 parts of oscillator. One is tank circuit. This tank circuit consists of what? Capacitors and inductors. See, one tank circuit consists of one capacitor parallelly to the inductor connected. Both are parallel, that is called as tank circuit. Next, amplifier. It is a device to amplify the weak signal. Okay, and see, this is output voltage, right? See this tank circuit produce the S signal that signal is fed into the amplifier. Either signal is very weak, if that signals are amplified by the amplifier, it gives the output. Yes, the same time a fraction of output signal fed into the tank circuit with the help of feedback networks. Yes, there are two feedback is there. One is positive feedback and a negative feedback. Okay, the positive feedback, the output voltage will is increased, and then the second one is negative feedback, the output will be decreases. Okay, this is that oscillator circuit, right? See this capacitor and the inductor and the exceptional one resistance. This is tank circuit. Okay, both are parallel to the inputs. Okay students, right? Now come to the output signal waveform. Yes, wave formation. See the first one, sine wave formation. That's why we call it sinusoidal waveform. This is sinusoidal waveform. The voltaging varying with the time. That is the with signal, analog signal. So this is the analog signal. Therefore, this type is a sinusoidal waveform. And the second one, see this one, square wave format. Square waveform. And the third one is ramp waveform. See this one, ramp waveform. And the last one is triangular waveform. Yes, these wave formation is used in oscilloscope. If you go to ECG, ECG machine is oscilloscope. In that machine, yes, they are producing these type of signals. That is sine wave, square wave, yes, and ramp wave and triangular wave. That's why these are the wave format. So oscillator produce these type of waves. Okay, right. The oscillator produced oscillations, one is damped oscillation, another one is undamped oscillation, right? First we can discuss the which oscillation, damped oscillation, right? Now see the first one. Typically when something is oscillating, there is an opposing force acting on the oscillation and causing it to slow down and comes to stop. Yes, if you were to swing a ball attached to the end of the string hanging on the ceiling, you would eventually see that it comes to a stop. So this is called as damping. This is called as damping. So this type of oscillation is nothing but damped oscillation. That means the amplitude of the oscillation going to decrease. Yes, when the time is increases, the oscillation comes to decrease and becomes zero. This type of oscillation is nothing but damped oscillations. Now see, if there are dissipative forces acting, then the energy is lost from the system, right? Example, simple harmonic motion. See, there are three damping: line damping, heavy damping, critical damping. See, this is time and this is amplitude. See this, the amplitude of the signal is going to decreases with respect to time. With respect to what? Time. See, first there are three type. No, first one is line damping, that is under damping. See, the under damping oscillations like this. With respect to time, the amplitude will be decreases and becomes zero. But heavy damping is nothing but over damping. See, this is over damping. The oscillation is going to constantly reduce. Okay, and critical damping is nothing but initially the oscillation is high, within a few seconds the oscillations becomes zero. Okay, that's why three lines. See this line is light damping, and this one is heavy damping, and this one is critical damping. Okay, okay students, right? The same one, the object still oscillates sinusoidally. See this displacement, but the amplitude decreases with the envelope of the decreasing sequence. So this is which one? Oscillation, damped oscillation. See, with respect to time, the amplitude of the signal is going to decreases and becomes zero. Okay students, right? Next is undamped oscillation. So see the undamped oscillation, if the losses incurred in the electric system could be compensated, the amplitude of oscillation would remain constant, and as such the oscillation would continue as identically against both external disturbances and changes in the initial conditions. Changes in that initial condition. This type of oscillation is nothing but undamped oscillations. Undamped oscillations, right? That means in undamped oscillations, the amplitude of the signal or the amplitude of the waves always constant, does not change. That is undamped oscillations. But if you go to the damped oscillations, the amplitude of the signal going to decreases with respect to time. Okay students, right? Is see the book and please underline the undamped oscillation definition and the undamped oscillation definition. Okay students, right? Undamped oscillations output. See, this is the undamped oscillations output. See the amplitude of the waves constant, no? Yes, this is undamped oscillations output. Okay students, right? Now come to the difference between damped oscillation and undamped oscillation. Damped oscillation and undamped oscillation. Okay, see this, the oscillations whose the amplitude decreases gradually with the time are called damped oscillation. The oscillations whose amplitude decreases gradually with the time are called damped oscillation. But if you go to that undamped oscillation, it's not like that. The oscillations whose the amplitude remains constant with the time are called undamped oscillations. Now, second point, such type of oscillations does not continue for a longer time and finally it causes. But if you go to this side, there are no power losses or provisions to compensate for the power losses. But come to this side, ample oscillation, the frequency of oscillation remains unchanged because it depends on the circuit parameters. And then this side, the amplitude of oscillation does not change with time. The amplitude of the oscillation does not change with time. But this side, damped oscillators will die out eventually. Damped oscillation will die out eventually, but undamped oscillators will oscillate, yes, indefinitely. So these are the difference between damped oscillation and undamped oscillation. Okay, you should know minimum 3 points. Okay students, right? Now come to that, yes, one important 2 marks and 1 marks. Barkhausen condition for sustained oscillation. This is important 2 mark and 1 mark, right? So Barkhausen condition for sustained oscillation. What does mean by sustained? Same output. Yes, that's why the condition should be satisfied. Yes, the loop phase shift must be 0 degree or integral multiple of 2 pi. Integral multiple of 2 pi. 2 pi is nothing but what? Pi is 180. 2 pi is nothing but 360. Yes, therefore 0 or 360. The loop phase compulsory, yes, 0 degree or 2 pi. At the same time, the loop gain must be unity. What is the loop gain? A beta. Beta is the gain, therefore A beta is equal to 1. The loop gain is A beta is equal to 1. And A is what? Voltage gain of the amplifier, and beta is the feedback. Feedback is nothing but or feedback is defined as the ratio of output voltage to the input voltage. Output voltage to the what? Input voltage. Okay, students? Right. Now come to the applications of oscillators. Applications of oscillators. 2-mark question. Now see this oscillator to generate a periodic sinusoidal or non-sinusoidal waveforms, right? And these oscillators to generate radio frequency carriers. RF means radio frequency carriers. And next, this oscillator to generate audio tones. Which tones? Audio tones, that is sound tones. And this oscillator to generate clock signal in digital circuit. Which signals? Clock signals in digital circuits, right? And this oscillator act as a sweep circuits in TV sets and CRO. What is CRO? Cathode ray oscilloscope. Cathode ray oscilloscope. Okay, students. So these are the applications of what? Oscillators. Transistor oscillator. Okay. Okay, students. Right. Now come to the example problem 9.9. Calculate the range of the variable capacitor that is to be used at tuned collector oscillator, which has fixed inductance of 150 microhenry. Okay, so inductance L is equal to 150 microhenry, and the frequency of band is 500 kilohertz to 1500 kilohertz. So 500 to 1500, that is the frequency F. Okay, calculate the range of variable capacitor. Calculate the range of capacitor C. Okay, students. So this is one data and this is the another data, right? We have to calculate the capacitor. So what is the formula? Yes, there is a formula. In feedback circuit, there is a formula is present. That formula is equal to F is equal to 1 by 2 pi root LC. So F is the frequency, root L is the inductor, C is the capacitor. So from that formula, I am taking the frequency F, which is equal to 1 by 2 pi root LC, right? So from this, first we are taking C outside. What will come? C square, right? If C go to outside, what will come? C square. Therefore F is equal to 1 by 2 pi root L into C square, right? If that C square come to this side, yes, and remove that square, what will come? Automatically this F not go to downwards now. That's why I see that 1 by, if C square go to this side, what will come? C square 1 divided by 2 pi F naught into S, what will come? Root L. But remove the square, so what will come? After automatically this square, no, square root of 1 divided by 2. Therefore 2 squares are 4, and pi square and F naught square already is there. Therefore F naught square already root L present. Therefore if the take square roots, cancel, we will get L. Okay, so C formula. Now substitute the values in this equation. So therefore 1 divided by 4, what is pi value? 3.14 into what is F frequency given? 500 into 10 power 3 whole square. Kilo means 10 power 3, that's the whole square. L is given 150 into 10 power minus 6. Okay, see therefore here 10 power 3, 10 power 6, here 10 power 6. So cancel. 1 divided by 4 into 3.14 the whole square, you will get 676 picofarad. So picofarad is the unit of capacitance. Unit of what? Capacitance. Okay, students, right? Okay. Next, for which frequency? 1500 kilohertz. For this frequency, what is the F value? Yes, 1500 into 10 power 3. Therefore, same formula, you have to substitute the frequency value 1500. Therefore, 1 divided by 4 into 3.14 the whole square into 1500 into 10 power 3 the whole square into 150 into 10 power 6. Therefore, here 10 power 3 the whole square 10 power 6. So 10 power 6, 10 power minus 6 and 10 power plus 6 will be cancelled. Therefore 1 divided by 4 into 3.1 for the whole square alone. So what will get? 75 picofarad. For which frequency? 1500 kilohertz frequency. Therefore, what is the range of the capacitor? Minimum range is 75 picofarad to 676 picofarad. Okay, this is the range of the capacitor. Okay, students, right? Thank you, students. Today class is over. Okay, we'll see you on next video. Okay, thank you, students. Thank you.